Welcome to day 4 of your AI journey. Today, we're diving into the beating heart of modern artificial intelligence: neural networks. If AI were a living organism, neural networks would be its brain. You're about to uncover how machines mimic the way we humans see, hear, and understand the world. So buckle up, because this is where things start to feel a little like science fiction. Except it's real, and it's already changing everything around you.
Imagine if your brain could be cloned not physically, but logically. A replica of how you think, recognize voices, interpret images, and even understand language. That's not just science fiction. That's exactly what deep learning and neural networks aim to do. Today, you're about to meet the digital version of the human brain neural networks. And trust me, this is where the real magic of AI begins. At first glance, neural networks may sound intimidating. But if you've ever seen a child learn to identify animals, you already understand the basics. Show a child a few pictures of cats and dogs, and they'll start spotting patterns. Fluffy ears? Maybe a cat. Barking sound? Likely a dog. Neural networks learn the same way by spotting patterns. But instead of neurons in the brain, they use mathematical structures inspired by them. Let's break this down in the simplest way possible. Picture this: you have an input layer, hidden layers, and an output layer. Think of the input layer as your senses. For example, your eyes take in an image of a cat. That image gets broken down into pixels, tiny dots of color. Each pixel has a value. These values enter the neural network through the input layer. Now, imagine passing that information through a series of decision gates, the hidden layers. Each gate makes a small decision based on the data, passing the result on to the next layer. At the end, the output layer gives the final decision: cat or not a cat. That's the core of how neural networks operate. What makes them powerful is their ability to learn. You don't need to program every rule manually. Instead, you give the network a bunch of examples and it figures out the rules itself. That's called training. If the network misidentifies a dog as a cat, it corrects itself by adjusting internal parameters, something known as weights and biases. Over time, it gets better, smarter, and more accurate. But how does this look visually? Well, if you've ever watched a video from the YouTube channel 3 Blue 1 Brown, you've seen neural networks come alive. Their animations make abstract math feel intuitive. They show nodes lighting up as data passes through, connections adjusting as learning happens. It's like watching a brain think in real time but digital. Now, let's talk about real-world applications. You speak to Siri and she understands you. That's a neural network processing your voice, breaking it into sound waves, translating it into text, then figuring out what you meant. You upload a picture to Facebook and it suggests who's in it. Neural networks analyze facial features, compare them to known profiles, and make a prediction. Google Translate? Again, neural networks at work, converting one language to another by understanding context, grammar, and meaning, not just word for word. This power comes from deep learning, a subset of machine learning that uses neural networks with many hidden layers. The deeper the network, the more complex patterns it can recognize. For example, in image recognition, the first layers might detect edges and colors. Middle layers could recognize shapes like eyes or wheels. Deeper layers might recognize entire objects, faces, cars, animals. But here's something most beginners miss. Neural networks are just a tool. They're not magic. They require tons of data, lots of computing power, and careful tuning. That's why big companies like Google, Meta, and OpenAI lead the charge. They have the resources to train these models on a massive scale. Still, you don't need to be a millionaire to experiment. Today, even a laptop with Python and a few open-source libraries like TensorFlow or PyTorch lets you build basic neural networks. You can start with simple datasets like MNIST, a collection of handwritten digits. Feed it to your network, train it, and watch as it learns to recognize the numbers 0 through 9. It's like teaching a child to read numbers for the first time. Let's go one layer deeper. Each neuron in a neural network performs a simple mathematical operation. It takes inputs, multiplies them by weights, adds a bias, and passes the result through an activation function. Activation functions like ReLU or sigmoid decide whether a neuron should fire or not. The magic happens when millions of these tiny computations work together. It's not one neuron that makes a decision, it's the whole network collaborating, like a team of specialists. The training process uses something called backpropagation. Think of it like this: you make a guess, check how far off you were, and then make adjustments to do better next time. That's the essence of backpropagation. It tells each neuron how much it contributed to the error and how it should change. Over thousands of iterations, the network fine-tunes itself, just like how you improve at a video game by playing repeatedly. Let's pause and bring this home with a practical analogy. Imagine you're baking a cake. The input layer is your ingredients: flour, sugar, eggs. The hidden layers are the steps: mixing, baking, cooling. The output is the final cake. If the cake tastes bad, you tweak your recipe: more sugar, less flour. Neural networks learn the same way. Trial, error, adjustment, perfection. Now think about how this technology affects your daily life. Netflix recommending what to watch. Neural networks. Your phone unlocking with your face. Neural networks. Fraud detection on your credit card. You guessed it, neural networks. They're not just confined to labs or research papers. They're everywhere, silently powering your digital world. But there's another side. Neural networks can be a black box. They learn rules, but often we don't know exactly how. That's a problem in critical areas like healthcare or criminal justice. If a model denies someone a loan or misdiagnoses an illness, we need to understand why. That's why interpretability is a growing field, helping humans understand machine decisions. Let's not forget the ethical questions. If neural networks can replicate human judgment, what happens when they go wrong? Who's responsible? As you dive deeper into AI, keep these questions in mind. Technology is powerful, but it must be used responsibly. The future of AI is not just about accuracy, it's about trust, fairness, and accountability. Back to learning, how can you strengthen your understanding of neural networks? Start by watching visual content. Again, 3 blue, 1 brown is gold. Their series on neural networks explains everything from vectors to gradient descent with stunning clarity. Then, jump into hands-on tools like Google's Teachable Machine. It lets you create your own neural network in a browser without writing code. You can train it to recognize gestures, sounds, or poses, great for beginners. Once you're comfortable, move to Python. Use libraries like Keras for building models quickly. Start with a few layers, then experiment. Change the number of neurons, the activation functions, the number of epochs. Watch how the results change. That's where real learning happens, not just in watching, but in doing. By now, neural networks should feel less mysterious. They're systems inspired by biology, powered by math, and fueled by data. And they're the foundation of almost everything in modern AI, from chatbots to self-driving cars. You've just scratched the surface, but even this glimpse should give you awe. You're not just learning about technology, you're peeking into the closest thing we have to artificial brains. In the coming days, you'll explore how these networks expand into vision, language, and decision-making. You'll build, test, and maybe even fail a few times, but that's the beauty of it. Neural networks don't get it right the first time either. They stumble, learn, and improve. Just like you? So here's your challenge today. Pick one visual explainer like the 3 blue, 1 brown neural network series and actually watch it. Don't just skim. Watch, pause, take notes, rewind. Let it sink in. Then try building your first neural net with an online tool or a simple Python notebook. Even if it's basic, you've now crossed a major threshold. You're no longer just a spectator of AI. You're learning to think like it, and that changes everything.